Okay, everyone, let's get straight into it. So in terms of an old exam question, here is one here. And what you have to do is you have to, in the first one, show what the mean price of a computer game is, or show, and it gives you what it should get you, but then you want to see the working out, and then comment on the spread of the data. And I'm going to make this question A and question B. Off we go. So these are all taken from old exams. And this graph to me looks like a histogram. So you're given a histogram, off we go. So Teddy, I see your question. Teddy, we will definitely be doing algebra soon. Also, when we start that exam revision, the exam revision course, which will start from basically in about 3 weeks' time, we will definitely do algebra. Also, the exam bootcamp would also, I imagine, have some algebra in it. Otherwise, there's also previous videos we've done on algebra that might be helpful to you as well. Remember, we record all our videos. And so there's lots of stuff, even in grade 10 and in grade 12, that might sometimes be helpful too. Okay, so how are we going to get the mean price? This is a grouped data table. So we know this first one, it's between 50 and 100, and there's 7. Now, you don't actually have to do the whole table. I'm doing it just to illustrate a point, but you could work out the mean from. I would love someone to put their hand up and explain how to do this, if you feel comfortable. I would be really appreciative. And if you could talk us through this process. So that would be interval, and that would be the frequency. So how do we calculate the mean? Now, this is actually going to be an estimated mean, guys and girls, because of the fact that we don't know what the value is between 50 and 100. So what are we going to use? So that's my first question. If we want to get the estimated mean, and we've got data that's grouped into a table, basically this is grouped data, what do we use as an estimate for this calculation, for the value? Who has an idea? Aha, Asimak, the midpoint. Yes, the midpoint is our friend, right? So when you want the estimated mean, you actually need the midpoint of the interval. We use that. So sometimes we add an extra column for midpoint. I might be going to put it on this side. So, and you use that. Yes, Arriva, the midpoint times the frequency. You guys are on it. Get this out the way. Oh, there we go. So, if you have, well, let's put the midpoint here. So midpoint, the midpoint for this would be 75. And there's two ways you could do this. The one, in this case, you probably want to show some working because they've given you the value already. I did show you in the lessons with the calculator, but basically all you're going to do to show the mean is you're going to say 75, the midpoint times the frequency, plus 125 times 11, plus, and you keep doing it for all of these rows. But there's one final thing that you have to do. You have to divide by something in the end. What do I need to divide by in order to get that 199.29? So I go through and I say there were 7 items in the 50 to 100 range. So I went 75 times 7 plus 125 times 11 plus it would be 175 times 20, and you just keep going for each of the intervals. But then I still need to divide by something in order to get the mean. The total number of items, and what's that going to be? It's going to be 70, or the total of the frequency column. So divide by 70. Yeah. And so you should then get about 199.29. We call that the estimated mean. Now, if you do it manually, that's the way you would do it manually. You didn't, and you could have done it straight from the graph. Are there any questions, guys and girls? I know that I'm not seeing a lot of stuff in the chat, so please do raise your hand and ask a question if you're unsure about something. Otherwise, we can move on to question B. Comment on the spread of the data. But I'd love to see a question if there is one. Lasanda, let's go to you. Hey, Lasanda.
Hello, sir.
How's it going?
I'm good. Sir, I wanted to know if do you always multiply the midpoint by frequency when you calculate the estimated mean?
Yes. And the reason, Lasanda, is because if you've got grouped data, you don't know. So like say this first row, you don't have a value for these 7 items. So you've got 7 items in this interval, and you don't know what value to use. So the most reasonable estimate is just to choose the middle of that interval. And what that does is it sort of pretends that there's 7 75s in the data set. And then we pretend there's 11 125s. And it's just the best estimate that we can use. Does that help?
Okay, thank you.
Pleasure. Okay, what about the spread of the data, ladies and gentlemen? Now, we haven't really spoken about spread when we talked about a histogram before, but I want you to think about where would the median be in this data set? And the median would be halfway through the data, right? And if we think about, there's a lot of data at the beginning, I think the median would be somewhere, we could work it out in terms of position, but probably the median would be somewhere around here, right? That would be about halfway through. There's 70 in total. I guess 18, that's 20, that's 38. In fact, that's already more than halfway through 70. So the median is probably somewhere in that position. Now, normally when we look at the skewness of data, we look at where the median is, and we look at the bottom 50% and we look at the top 50% of the data. So how do we, who has an example of the spread of this data? Or who has an answer for that? Any ideas? I'll give you a bit of time. It looks to me like the bottom 50% is quite close together of the data, and the top 50% of the data here is more spread out. You see how like 50% of the data fits into that range, and 50% of the data fits approximately into that range. What do you guys think? What sort of skewness do you think this has? Well, the spread of the data is another way of saying it. Komotsile has put the answer in. Who agrees? Who disagrees? Aha, Zinkler agrees. Guys, I agree. This data set is positively skewed or skewed to the right. And in statistics, we often talk about the tail. Can you see the tail of the histogram? It's sort of a long tail going to the right. And so the top 50% is more spread out. And then that's, if you imagine a box and whisker plot, it would probably look, you know, something like, maybe not perfectly like that, but something like that. You have a longer tail to the right-hand side. Okay. Are there any questions about that? Was a bit of a toughie to start today, but I thought I wanted to show you that different type of question. Okay, well, let's move on then. Okay, so here is another old exam question. And let's just move the other one out the way. It says, the box and whisker diagrams of two data sets A and B are shown below. Write down what is common to both data sets. And then it says which data, well, let's start with A. I want everyone to do A for me. Let's do A. Let's do it. Or if someone's got answers, they can just put their hand up and answer for me. It's quicker than writing, much quicker than writing. Who has an answer for us? Okay. Let's see. Is there a hand up? Let's have a look. Atlihan, are you trying to, can you hear us? Are you giving an answer? So I see in the chat, lots of students, and I agree with you, you're noticing that the min value is the same. So that's the first one. And you've also noticed that Q1 is the same, or the lower quartile. That's different, and that's different. Okay, so first answer is min and Q1 are the same. Which data set is symmetrical? So now I want you to answer this question. Which data set is symmetrical? State the reasons. There's two data sets. There's set A and set B. Which data set is symmetrical? So you're oh, there you go. iPhone, you can let me know. iPhone, you can unmute yourself and let us know what answer you think it is.
It's data set A because the mean and the median are equal.
Okay, I agree with the A. The A is perfect. The reason we would normally say is we'd say the lower 50% of the data is kind of just as spread out as the top 50%. Or we could say the spread on either side of the median is the same. So the min and max, does that sort of make sense as a reason? Okay, I see I've lost iPhone there. So I absolutely agree with iPhone's answer of A. So it's perfect, definitely asymmetrical. Just in terms of the reason, we would normally look at the bottom 50% and the top 50% of the data and say that their spread is the same. They're the same amount of spread out. So I'll just say reason spread the same on both sides of median. So that would just be a reason. Like I'm just saying that it's the same. It's symmetrical, basically. Okay, then for C's question, is the other data skewed to the left or skewed to the right? Give a reason. Okay, I want an answer for C. Who has an answer for C? You can pop your hand up if you like, or you can put it in the chat. I always look at the top 50% of the data, so and the bottom 50% of the data when I look for skewness, or I can look for, the top 25 and the bottom 25. But normally, so that's the top 50% of the data. That's the bottom 50% of the data. It looks like the top 50% is way more spread out. And so we would say it's skewed to the right. So I suppose I should just write skewed. Right? Or we could also say positively skewed. And then what is the reason? Well, basically, the top 50% of the data is more spread out than the bottom 50%. Okay, so I'm not going to write that, but essentially that's the reason. You can clearly see the top 50% is more spread out than the bottom 50%. And so you get, when it's more spread out, you get a tail. And you can see the green bit is the tail of the top 50%. It's longer than the bottom, the tail to the left. Okay, guys, give me a thumbs up if you're feeling okay with everything we've done. Thumbs down if you're feeling a bit like, whoa, slow down, boy. Okay. Awesome. Okay. Okay, well, let's move on to the next question then. So you are given a little story, and it looks a bit like, oh, this is like a lot of words. So let's just read through them together first. A medical aid scheme needs information on the number of times people visit a doctor in the year. The following frequency table summarizes the visits to the doctor over a year of a random group of patients. So this is a grouped data table. So we're definitely dealing with grouped data. And then we see below, we see an ogive below. Okay, question 1. State the median class of the above distribution. So I want everyone to answer that first. What is the median class of the above distribution?
Mr. Ace, can you take a question from Lisa Kanya?
Lisa Kanya, let's have a look. Lisa Kanya, let's go to you. Yeah. Lisa Kanya, we can unmute you. Can you hear us? So one of the things that in order to find the median class, I'm going to have to get the n value, like how many items of data are involved. And I'm actually going to have to add up the frequency column to do that. So I get n of 150, or cumulative frequency of 150. So that might help you guys as you try to work out the median class. Well, I suppose I could have looked at the ogive too, because the ogive is in line with 150. At least I know that I'm right. If there are any questions about how to find the median class, please do, let us know. So the median is normally in the middle in terms of position. So if you're going from smallest to biggest, how do I find the median? What's the first step? I'll give you a hint. We normally always calculate the position of Q2. Okay. So the position of Q2 would just be a half times n plus 1. So a half times 151, it's position 75.5. Now, where would that be? Which interval would it fall into? Well, it wouldn't be in the first interval. And if I add the next one, I get up to over 100. So the median must fall somewhere in here. And so since they asked for a interval, the median interval would be from 5 to 9. If they wanted you to get an exact estimate, you would just choose the middle of the median interval, but they asked for an interval. So the median interval will be from 5 to 9. So the reason it has to be that is you can imagine up to this point, we've got up to 103 items. At this point, we had 32. So sometimes you would add a cumulative frequency column, but basically we only needed to get to the 75th item to get to the median. By the end of the second interval, we've already got to 103. So it must be in the second interval, which is 5 to 9. Okay. Any questions or comments about that? Okay, now what I want you to do next is you're going to use the ogive. So this has been drawn for you already. You have to estimate the median and the lower and upper quartiles for the given data. So use the ogive to help you estimate what Q1, Q2, and Q3 will be. kind of did this calculation already. So I get positions 37.75 for Q1 and so on. The challenge now is getting a value. So what answer do you think we're going to get for the estimate of Q1? So 37.75 should be about and 75. Mhm. Okay, so see if you can work out what are the estimates for just wondering. All right. So I see Owami and Zinkler. So to me, yeah, it looks, I mean, it's basically for Q1, we'll go with 4. I mean, if they really want it to be difficult, you could say 4.2, but 4.1, but essentially we can round to the nearest one in this case. For Q2, for me, it looks like it would be 6. And for Q3, it would be approximately 10. 112, 113, actually maybe. So in this case, there's going to have to be some leeway. I'm going to the nearest value. But as long as the basic, so let me just check, 37.75. That would be too, yeah. No, I think it's about 4, 6, and 10. I wouldn't say 12. 12 would be a little bit too high, Owami. If we were using decimals, I would go with about 4.2 for Q1. I would give it about 6.5 for Q2, and about say 10.4 for Q3. But for our purposes now, it says round to the nearest integer. So since it says round to the nearest integer, I'm just going to go with 4. And then actually, when I look at it, the nearest integer, that one will be 10. And then it is a question of 6 or 7 for Q2. I think both of those could be given as approximately correct. All right. Are there any questions or comments? And then I think it is time for a bit of a break. Are you sure there's no questions about that? Well then, ladies and gentlemen, I would like you to stand up on your feet, and I would love you to stretch and invest in your own body and stretch it out. There we go. if you turn your cameras
Guys,
on,
switch on those
I'll play you a song.
cameras.
If you turn your cameras on, I'll play you a song. How's that? There we go. Come on, guys, stretch it out. Show me a song. You can show me your
Some
stretching.
bargaining.
I'll play you a song.
Shout out to Lusanda, yes.
There we go. Look at those lovely faces.
Shout out to Ari.
Ari. Oh my goodness.
Shout out to Lee. Yes, guys. Give your mind a break.
Oh, flip. Okay. Who can guess that song? Anyway. I loved seeing all those faces. Is that what I have to do to see everyone turn their cameras on? I have to...
Yes. Really?
Literally. Okay, so that song was by the Beatles. It was Blackbird. Close, Arriva, close. All right, then it's time for our brain break. I want you guys to work out the mathematical word from this anagram. So you have to work out what mathematical word can you make with these letters. Oh. I'll give you a hint. It's almost like guessing something a little bit. It's almost like guessing something. That's my hint. Oh, I gave
Nice
it away.
one, guys.
Give it away. Oops. Okay. All right. Respect. Not bad. Not bad. Then what about the second one? So I'm not going to give hints yet. I want you to. So the first one is estimate. Well done to everyone who got that. Well done everyone who tried. So Asanda, what we're trying to do is we're trying to make a mathematical word from the scrambled letters. So it's called an anagram. It's when you take the letters of a word and you mix them up. Okay, so I'll give you a hint for this one. Think of how do we measure, like, if I want to measure how far away something is, like what could I use? That's my hint.
Yay.
Look, doesn't, like, once those hints come in, it's like,
Yeah.
oh, man.
The juices start flowing.
Yes. Well done. Okay. All right. Well done, everyone. I quite
Well done,
like,
guys.
it's nice to have a little, we'll bring the equation puzzles back now, but it's nice to use a different part of our brain. And then, yeah, before we continue, just make sure you've had your proper stretch. And
I feel like they got that way faster than I did.
yeah, they had a bit more help. I got it, maybe a little bit. I unleashed these on label before the lesson. They were tough. Without hints, they were tough. Okay, let's go to the second part. Let's go with, let's try this one. So let's just try and do 1.2.1 first. So this isn't grouped data. This is a set of, this is a list of data, and it's in ranked order. Can you calculate y for this data set if the mean for the data set is 41? So try and do that. And what working would you need to do? So normally for the mean, it's the sum over the number of items. So that would have to be 13. Now what's on top? If I add up all of these numbers, what do you get? Obviously, you can't add the y, but what do you get if you add up all of these numbers? Yes, Faith. So if I was adding up everything, Faith, 439 plus y would be the sum. Now, who knows that? How am I going to find the value of y? What other information do I need? What can I still use? Who has, maybe you can raise your hand and tell me what to do. What information haven't I used that I can still use? The mean is 41. Yes, Asanda. So can't I replace the mean with the value that they told me? So then, isn't that an equation that I can solve? How would we solve that equation? And what value do you get for y? What value do you guys get for y? So if you do this calculation and you want to bring the 13 across, we get, it's times 13 on both sides. So we get this. And then what is 41 times 13? So that's 533 minus 439 is y, which is 94. Yeah, 94. Fantastic. So we know that this value is 94. Okay, second step. Luckily, they showed you if y is 94, so we know we're correct. Calculate now for me the standard deviation of this data set. Now, this is where we have to go into our calculator mode, and we need to put the data items, including 94 in, and we have to practice our calculator skills. So what is the standard deviation of this data set? Komotsile, the 439 you just get by adding up all of these items and this one. And then we set up an equation to figure out that y was 94. At the moment, we're trying to find the standard deviation using the skills we've learned in earlier lessons. Pleasure. So here you can see our model answers. So you should be getting 30.94 for the standard deviation. And I just want to pause for a moment to ask, are there any questions about that? Are some students? If not, now this is a little bit of a harder one, so I don't want you to worry too much. Let's have a look. Okay, let's try and do this one. So it says, the mean time before another group of 6 students needs to recharge their batteries of their cell phone. Combine these groups and calculate the overall mean time needed for these 2 groups to recharge their batteries. That's a very wordy way of saying something. So what they're saying is there was another group of 6 students. So there were 6 students. And their mean time was 18 hours. So that's how long they mean to recharge their cell phones. There was the original group of 13 students. And the mean time for that, for those students, was 41 hours. Combine these groups and calculate the overall mean time needed for those 2 groups to recharge the batteries of their cell phones. Guys, I'm just going to actually show you the answer on this one because it's just a bit too wordy to be worth diving in the deep end. Basically, all you would do is this. Okay, so you have the one group and you would go 41 times 13. So it's basically 41 times 13 gives the number of hours that the first group took, which is 533. And then the second group has 6 students and it's 18 hours is the mean. So you go 6 times 18. So how do we get the mean of the new group? All we need to do is add together the 2 total hours. So 533 plus 108. And then we add together the total number of students, which is 19. And so the mean time, the new mean time would be 33.74. Okay. But that just felt a bit clumsily worded. Okay, let's squeeze in one more question and then we'll call it a day for today. Let's do these questions. So over to you guys. I want you to do 1.1, 1.2, 1.3. Off you go. And then if you've got the answer for 1.1 and 1.2, why don't you raise your hand and let me know your answer? I'd love to hear from another human. Oh, I see someone's hand is up. Level, can you unmute them? Is that Lee? Thanks.
Hello, sir.
Hey, Lee, how's it going?
I'm good, and you?
Very good.
I'm getting my interquartile range as 10 because I took Q3 minus Q1.
Okay, so we go to A and we take 30 minus 20 and we get 10. I agree with you, Lee. Fantastic. And for 1.2, the
1.2, I thought negatively skewed.
Yeah, I agree. Negatively skewed or skewed to the left because we see how the lower 50% has that long tail compared to the top 50%. Yeah. Awesome. Very good. Okay, let's try and do 1.3 and 1.4 then. Who wants to have a go at 1.3 or 1.1.3? Hmm.
We have a hand from Lee again, Stace.
Aha. Let's go for Lee. See if you
Hello
agree.
again, sir.
Go for it. What is it?
I'm getting 29.
29.
Because I
Let's have a look. So I get, wait, let me make sure I'm looking at the right question. So supermarket B, which is the second one, your biggest value is 35. Your smallest value is 6. And so I also get 29. Yeah, you're on a roll today, man. Well done. Okay, last question. So guys, I see a couple of you got something different. Let's just check that so when we talk about the range of the data set, supermarket B is the second one. The highest value is definitely 35. And what we have is the lowest value is definitely 6. So 35 minus 6 would be the range. The range is the difference between the biggest and the smallest. Okay, so that's awesome. It's good news that we checked that question. Okay, last one. During the 2-week period, which supermarket receives 25 or more deliveries per day on more days? Explain your answer. So this whole story was about deliveries and how many deliveries in a 2-week period. So how many deliveries are made? Which one do you think it is, and how would you explain it? Okay, let's go to Lee. Lee, what do you think?
So I would say it will be supermarket A.
Okay, and what are you looking at for evidence? Which one will that be?
I'm looking at the top 50% range.
Yeah, exactly. So you looked at 26. So you're looking at that part. Exactly.
Yes.
Yeah. And you can see, whereas the other one, the top 50% is only, I mean, some of them are above, but essentially clearly supermarket A has like basically more values above 25. More than 50% of the data is above 25.
Yes, sir.
So I agree with you, Lee. I would say it is supermarket A, and we can say for the reason more than 50% of data is above 25. Whereas with supermarket B, 50% of the data is, yeah, you can see that its median is basically lower, right? It's at 20. And so 50% of the data is above 20, but it's not above 25 as the question was, or 25 or more deliveries. Okay, that's a bit of a toughie, but I hope that as we kind of do more and more of these, those types of questions get a little bit easier.